I'm excited to have all of you on this call to talk with us about interoperability, to learn about interoperability, what NIST is doing in the standards community to advance interoperability, and I think most importantly, why it is so important for what you're trying to do with electric vehicles in Connecticut. So let's see, can I get it moving? There we go. So first thing we'll do is talk a little bit about NIST and what the benefits of interoperability are. And then we'll get into the smart grid framework and some concepts and tools that we've developed to understand interoperability and explore it. And then we're going to dive into the testing and certification issues and interoperability profiles that Chris mentioned, and follow up that with an introduction to the interoperability profile we are currently developing for managed charging of electric vehicle fleets, which I think is quite relevant, obviously, to what you're focused on here, as well as a good introduction to what one of my colleagues is going to focus on in a future conversation. Okay, so NIST is old. We've been around a long time. We've always helped in the electrical sector. We've tried to make sure that things like light bulbs and batteries and other stuff have functioned as well as they've claimed they would, right? It's pretty simple history that we have, and it's just we've been involved with it for a long time. Our mission today is to use measurement science to inform standards and drive technical innovation through the US economy. So, the short of all of this stuff is that measurements are the foundation of both the problem statements that describe the work that needs to be done for our infrastructures and grids, and measurements are also the way that we assess the value of new technologies that we're putting onto the system that solve the problems we're facing. So measurement is pretty important from a regulatory perspective. Obviously, we want to make sure that people are getting what they're paying for. This is what NIST does, and so we've been around a long time doing it. In fact, right, measurement has been a part of what the government does from the very beginning, and measurement combined with technical standards are critically important to all forms of commerce, the electric grid included. So then the question is, why is NIST doing smart grid interoperability? You might think that interoperability is a little bit different from pure measurement, and in fact it is. But right, the simple answer is always, well, Congress told us to. So Congress tells us to do something, so we're going to do it, right? They told us to write a framework, and they did that in the Energy Independence and Security Act of 2007. But I do want to highlight some of the important language that we have in this law that help guide what we try and do here, right? So first, our job is to modernize the grid. We're not here and we're not doing this to just keep the old grid running. We want to have a modern system. Second is that NIST is supposed to coordinate the development of the framework. So we work with stakeholders and contributors across the power sector, and we use their input to inform the ideas that are expressed in the framework. So what you're seeing is not, some government researcher sitting in a room by ourselves dreaming big, big dreams. It is a reflection of our interactions with the community and stakeholders around the country and the world. The framework also must focus on enabling all electric resources to be part of the solution. So we're not just looking at legacy equipment, and we're not just looking at the new stuff. We're looking at how everything works well together. I also, though, want to highlight this word interoperability. Let's see, there you go. This is what we are focused on, and it's a pretty important topic. It's why we're here today. And before we get into this, I want to provide a little bit of context for the 2021 revision of the Smart Grid Interoperability Framework. So our first framework was published in 2010. It included these grid domains, that's those 7 clouds you see in the middle of the diagram. It described the difference between electrical flows, which are the dotted line at the bottom, and communications, which are the solid lines. It identified a list of relevant standards, which at the time was only 25 standards long. And it did something about cybersecurity, although if you look at that lower right-hand block diagram, I defy you to secure your power systems using that, right? So that's where we were about a decade ago. There have been 3 frameworks published since then, right? I like showing this slide because if you ever see a publication coming out of NIST and it's got a fancy color graphic on the cover, it's a fake. It's somebody's trying to trick you into thinking that, that what they did is what we did. We do boring government documents. They're just white, plain, covers. This is what we do. But why do we need a new one, right? So this is the really important topic. So the things that we're deploying on the grid are changing, right? This is the trend of solar prices over time. Solar is so cheap. What we're putting on the grid is just changing, and it's different. We need to communicate differently than we did before. Also, the competitiveness of small scale, modular, and lower capacity factor technologies has led to a massive shift across our industry in the pace and type of infrastructure build out. So this is a chart that I published in a paper, I think just a couple weeks ago. And it compares the size of every bulk system connected generator put on the system from 1960 to the present. You can see two really important things. First is that the pace of capacity deployments is accelerating dramatically. The amount of bulk capacity that has been deployed in the last 20 years is actually the same as what was deployed in the previous 40. So we're building things out faster. Second, while the 20th century construction overwhelmingly focused on centralized generators that were larger than 500 megawatts each, 70% of the generators built in this century, in the past 20 years, have been smaller than 200 megawatts. And that carries with them a more distributed system topology and an increased demand for communications and coordination. And I will emphasize, this doesn't include anything that's not connected to the bulk system. So what we're doing in the distribution system is a further amplification and extension of these trends that have been going on for the past several decades into a more complex and distributed system architecture. Oop, that went backwards. Sorry about that. Boy, all right, here we go. And the data and the information that we have available to us is simultaneously changing in really dramatic fashion. So modern energy technologies are on some ridiculous cost curves, right? We already looked at solar, but I think what's really important here is if you look at that orange line at the bottom of that graphic, that is the line for sensors. Sensors had a 98% cost compression in 8 years, according to the International Energy Agency. That means data is available. We can observe things. We can measure things. We can actually know what's happening on the system in ways we never could before and cost effectively. Also, 90% of the world's data has been created in the last 2 years. Most electricity demand is projected to eventually flow through network-enabled devices. And the range of sectors and technologies that will actively impact energy demand and energy management is really exploding. Each one of these little dots represents a different sector, according to the International Energy Agency, that is involved with our modernization and decarbonization efforts. So, also, we have changing motivations, right? I don't need to tell you that Connecticut has been a leader in some of these policies, but even the federal government now is moving to ask our grid to do things differently than it did before, right? Power systems that were historically focused only on getting electrons to the customer are now trying to do other things as well, right? In this case, it's decarbonizing, but we know that it is a whole lot of other demands being placed on the grid as well.